Well, I think right now with 3D printers, we're kind of at the beginning of a consumer market. And what we're seeing, there needs to be a little bit more focus on the content side of things and having a streamlined way of getting that printed. So it's a bit more software and content that needs to be focused on. And like with the hardware, there's some more improvements that need to be made to make it very much plug and play type of application. But I think a lot of it's going to be more focused on the content side. And so if you talk to people right now and you say, are 3D printers cool? And they say, yes, they are. And then you say, well, what would you print? And then they say, I have no idea. So it's really kind of more coming up with that ecosystem of kind of software and everything to where it just works, and so that people understand exactly what they would do with it. And I think probably the first application that we'll see that's very consumer focused and friendly will probably be toys. Yeah. So when I first started looking at doing the Makibox project, I was using an original RepRap, which is an open source design. And literally that particular one, it was kind of a group project that we put together as part of a hackerspace. And it took about 80 hours of assembly. Yeah, exactly, 80. 80. And that's not really that uncommon for that particular design. And then after we did that, because it was so complex, it was also very difficult to calibrate and to understand. Like if you didn't really know what was going on, it was very difficult to diagnose if something did go wrong, why it was going wrong. And so the company Makeable actually started out as a crowdfunding platform. I was using the RepRap for prototyping parts, and I spent basically 3 days straight trying to get some good ABS prints, which is a type of plastic. And basically, after those 3 days of tuning and modifying and all this stuff, and of course the printer is completely different than how it started because I modified it, and then so you can't really share your experiences directly. So if you modify the design a lot, you can't share like your printing files between the RepRaps. So what I saw was that basically it takes a lot of time to do it. It takes a lot of time to just get it working, and it takes a lot of time to basically learn how to master it. And so I said, okay, you know what? I've done children's toys and consumer products and everything. I'm a mechanical engineer, basically do robotics and all sorts of stuff. So I said, okay, we'll do one for, our target was $300 US as a kind of a kit price, complete out of the box. Basically like if you went to IKEA and bought a 3D printer, right? And actually, so we actually, these are the instruction manuals for our first generation. So basically what we did is we set the price point first. And so by doing that, what you do is you force yourself to make design decisions to keep things simple, to keep things inexpensive. Yeah, so that's an example of, we ended up with 14 steps. So it takes maybe about 2 hours for most people. I can do it in about an hour, but I've been told I have an unfair advantage. But by making it more simple, what we've done is that also allows us to reduce the cost. And so basically, it's kind of by focusing on a certain price, you design for that price, and then by doing that, then everything just kind of works together. And everything was designed very much from the ground up to work together. So with most of the other printers, they're kind of in this price category. They're kind of, there may be certain bits of it that are designed as a unique thing, but most of the, say, like the part that heats up the plastic or whatever, they'll have borrowed it from somewhere else, and it's fair. It's an open source type of system, so it makes sense that that's how it's evolved. But we really, for the most part, we designed our own things. We referenced the open source hardware and everything, but then we said, okay, how can we make this more manufacturable? How can we make it cheaper? How can we make it more consistent? And so like pretty much every major system for our design has been really streamlined and reduced in the number of parts and everything. And that's how it becomes cheaper. So yeah. So basically we designed it that way, so it is. Yeah, so we're basically, our output quality is comparable to the machines that are, $2,000, like 10 times the cost, basically. So like this is a typical test print that everybody does. So there's certain things that everybody does that's like, kind of, okay, show me what this looks like, and then you kind of have an idea of what the quality is. So, so basically our output looks very similar to the ones that are 2 to 10 times more. So yeah, from a quality standpoint, we at least are similar in quality, but at the same time, we actually have better luck with certain types of plastics. So this is actually using ABS plastic, which is it's probably what a lot of your equipment has as the bodies. And so like in daily use, you see air conditioning, shells or the remote controls, things like that. It's very common in plastic. The reason why ABS is kind of cool to use is you can do post-finishing very easy on it. So you can paint it, or you can sand it and do stuff or whatever. The other type of plastic is a bio-based plastic called PLA, and it's a little bit less friendly towards post-finishing stuff. So usually the color that you get as the print, that's kind of what you're gonna, that's kind of what you're stuck with for the most part. You can paint it, but it's not as compatible with most materials and things like that. Yeah, so basically, the fact that we can out of the box print, like standard, like this is one of those, like this is yet another test print that everybody kind of has to do at some point. So with our machine, we can print this guy in ABS, which a lot of people will have trouble just getting it to stick. So one thing that happens with many printers is the base will curve up because it's just the way the ABS is. So a lot of times you'll get through part of the print and then it'll pop off at some point, and all of a sudden you failed, right? So what we can do with our machines, because the mechanism is very consistent, we can come up with, for a particular color, we can say, okay, this is your Yoda head in red, just run it, right? And even between different plastics, there's some just small settings that you can do and still use the same files. But that's something that nobody else really is doing very easily right now, is just being able to take okay, we know this works on this one printer. Okay, you know that it'll work on the other printers, because everybody tends to have a little bit more variation in their machines. So, kind of looking back, like my whole exposure to 3D printing, the first time that I actually saw something that had been 3D printed was back in the late 80s. Okay, yes, I'm actually that old. And it came off of a commercial, what's called an SLA. So it's a process. So what we do is, with our process, we heat up plastic that's coming in almost like a thick fishing line. We heat it up and then we draw each layer two-dimensionally, and then you just keep adding it up. The first one that I saw it's a similar process, but it's quite different. What they do is you've got this vat of UV resin. So it's like a glue that when you shine a laser on it, it hardens. And so what they do is you start out with a table and you draw the first layer in the resin, and then you drop the table down, and you just keep on, you do that and you keep dropping it down. But the parts at that time were very fragile. And then also the CAD technology for drawing the parts was, like I was learning AutoCAD 9 at that time, which, and that was cutting edge for kind of like entry level CAD stuff. And that didn't actually do 3D models. So most people didn't have access to the tools to do the 3D models in the first place. Now, if you go ahead, maybe five or 6 years later, when I was in university, so we were using laser cutters. We were using kind of early accessible 3D printing systems. So we had one that it would cut a sheet of basically label paper, and then you would manually stack up each one and create an object that way. And so I'm basically over the last 20 years, I've seen this technology go from rapid prototyping to something that you start making like first semi-working prototypes. So like you could get something that would work well enough for you to kind of test out the concept without going through traditional machining. And then like more recently, we've started seeing accessible like metal printing and food printing. Like we're going to be looking into printing chocolate and things like that. And so I think basically what I saw was this technology needed to be pushed just a little bit harder, so it becomes kind of consumer friendly, even though I didn't really see a fit within the market, as far as that it basically, there wasn't really a clear, it's going to be a retail type product. You have to get it into that price range before you can validate that. And so that was kind of, okay, let's see what happens when you make something cheap enough and accessible enough. I think it's pretty vital. So I grew up around in a small town just north of Atlanta, Georgia. So I had 10,000 people in my hometown, and even there we had at least reasonable curriculum for science and technology, I would say. And I think with any place, I think there is some movement towards a lot of a service economy and all these things, but you need to have people that understand how things work. You can't have a whole culture around just consumption and everything. You have to have some people to actually continue developing new things. So yeah, I think it's pretty important. But honestly, the best way to do that is just to enable like the freedom for kids to experiment, give them the tools to be able to try things. I was just telling a story about when I was in middle school, we had a model rocket contest, and this would never happen nowadays. And so the only model rocket that I ever built was a 5-stage rocket, like this tall, right? And so I went to the store and I got this model rocket kit that was just a box of parts, right? There weren't any instructions, anything. So I was like, okay, let's just, 5-stage rocket. So I took it out, put it on a launch pad, hit the go button, goes up about 50 or 100 feet, and then it promptly takes a right-hand turn and starts circling the field, right? Now, you would think that by endangering everybody and whatever, that I would have gotten in trouble, right? But instead, I actually got an award for the most creative flight path, and nobody criticized the fact that I had pushed the limit. Nobody said you should be more safe. everybody that was there accepted that, there was some risk, but at the same time, without that risk, you can't, have new things. So, yeah, so I think a lot of it is not just education, but it's also freedom to experiment and the support that when people fail to say, you know what, it's good. It's okay to fail.